Okay, now let's discuss in this video monomials under a radical sign, how to determine if a variable raised to a power is a perfect square, and if so, how do you do that? And I believe we only have square roots here. So the way that you would do that, just the basic simple rule is this. If you're looking for a square root and the base is raised to an even number, that's a perfect square. Perfect square monomial. If you have a base raised to an odd number, it's not a perfect square. And the easy way to do it, just take the power and divide it in half. So let's say I've got a to the power of 10. A to the power of 10 would be a to the fifth times a to the fifth, because when I write that base one time, I would add those two numbers together, and that would give me a to the 10th. So the way you would determine the perfect square, you would write the base or the radicand once, and then when you bring the exponent out, you would divide it in half, so you would have a to the power of 5. Let's look at a few of these before we go on and do the odd. So number 1, 2 is an even number. So when I bring this out, I write the base once, and I've got the power, I've got the exponent of 2. If I divide that in half, that's just x to the first, or x. Let's look at number 2. K is raised to an even number, 10. 10 divided by 2 is 5. The square root of 9 is 3. So the simplified answer for number 2 would be that. And let's go down and just catch part of this. Let's pretend like I'm going to change it just temporarily for the video. 25 is a perfect square. 6 is an even number. 6 divided by 2 is 3. So if number 5 were just simply that, that would be my simplified answer. And let's just look at number 7 just to change it for a second. So if I were just simply trying to find the square root of b squared, 2 is an even number, so that would just simply be b. You could think of dividing 2 in half. That's just going to be b to the first power, or just simply b. Okay? Now let's go back and do the odd, when the variable is raised to an odd power. So when the variable is raised to an odd power, I like to think of it like this. I have n to the fourth times n to the first, because going back to properties of exponents, that's going to be n to the power of 4 plus 1, which is n to the fifth. So the largest perfect square factor of n to the fifth is n to the fourth. So all you do is just take the odd number, subtract 1. Let me show you all the steps for that, the way you mentally think about it. 5 minus 4, or 5 minus 1 is 4, so that gives me n to the fourth. But I would still have n to the, 1 n left over, because I have n to the fifth. So you just simply take the odd power, subtract 1, that becomes your perfect square, and then you always have one variable left over to the first power. So here I'm going to have the square root of n to the fourth times the square root of n. So the square root of n to the fourth is going to be n squared, an even power. So this is going to be n squared, and then I would have 1 n left over. So that would be my simplified answer for number 3. Let's do number 40, and I'm going to ignore the numerical piece for a minute. So I've got a to the 19th. Well, 19 subtract 1 is 18. So my largest perfect square factor is a to the 18th. And then I'm always going to have 1a left over. Half of 18 is 9, so that means that my answer is going to be a to the power of 9 times 1a left over under the radical. That would be my simplified answer for number 40, or for number 4 rather, ignoring the 40. So let's just focus for a minute on just how to simplify powers on variables. Let's look at number 6. So in number 6, p is raised to an odd number. So that means I'm going to have p to the 14th times p, and all of this is under the radical. And q, 9 minus 1 is 8, and I would have 1 q left over, and then I would have r. So my perfect square is going to be p to the 7th and q to the 4th, half of what's here. And then what would remain inside would be the p, the q, and the r, all to the first power. And we'll pick this up more in class, but I think that's simple enough. And then as always, just to simplify the numerical piece, or the numerical part of the radicand, that's a skill that's already mastered. So you would continue that skill and then just add on what we've just learned. Let's do on the video number 8, and then I'll stop the video. So number 8, I have 9 times 3, and then I'm going to have n squared times n. 3 minus 1 is 2. So my two perfect squares would be the 9 and n squared. So they come out as 3n, and then what would remain under the radical would be the 3 and the n to the first. So there you have it. That's your simplified answer for number 8.